All right, I think we're rolling now. Today we're going to talk about the chain rule. And this is going to open up, actually, some ways to do derivatives for a lot of functions you haven't been able to in the past. And basically what the chain rule is allowing you to do is to take derivatives of substitutions. Okay, so if you have some kind of a function where you can see like an obvious substitution happened, then it'll let you do that, where maybe we weren't able to do it before. So like, for example, we're going to come back to this one in a little bit. If I wanted to find like the derivative of something like that, sine of x squared. So at this stage, we could find the derivative of sine x. We could find the derivative of x squared, but we're not capable of finding the derivative of sine of x squared. Okay? A common misconception is that you would just go, well, I know the derivative of sine x is cosine x, so the derivative of sine x squared should be cosine x squared. And it's not. It doesn't work that way. You can't just take whatever's in there and then just do it the same way. Okay? If it's something other than just x, you have to apply the chain rule to do it. Okay? And so in this one, I said it's a substitution type thing. You guys all see how the substitution that took place would be, and I'm going to use the letter U because that's what it gets used consistently with this. But so the substitution that took place there was x squared, bless you. Okay, so if I had just like the sine of U instead of the sine of x squared, well then we could do it, right? But as it is right now, we can't. So we're going to use this idea of figuring out what the substitution was and then try to kind of work backwards to figure out what the derivative is from that. So to show you how the chain rule works, I'm going to have you do the derivative of a function that doesn't require the chain rule, but then I can show you how the chain rule and just doing it straight up gets you the same thing and why it works then. Okay. So we're going to come back to this one. I'm going to hop over here for now. And we're going to look at f of x equals 6x minus 10. And we all know what the answer to the derivative of this one should be, right? What should it be? Should be 6. Okay. So I'm going to turn this one into a substitution problem, though. Okay? Just because I can. I'm going to make it 2 times 3x minus 5. And my substitution is going to be this little piece. Whoops, it's supposed to be an arrow. It's going to be this little piece here. So my u, in this case, is 3x minus 5. So if I do that, then I end up with a new function. I'm going to drop the f of x and just make it y, just so it's easier to look at. So if I change that 3x minus 5 into a u, then y is now equal to 2u. Okay, and so I got a couple of derivatives I want you to do here. And I'm going to use Leibniz notation because it really does make more sense in this case. So I'd like you to do, what's the derivative of y with respect to u, which would be focusing on this little equation here, right? And then I want you to do the derivative of u with respect to x, which would be this guy over here. Okay? So what do you get? What is dy du? Let's start with that. 2. Yeah. And then hop over here. What is du dx? 3. And what did we say the answer to this derivative was supposed to be at the beginning? 6. How do you suppose I could take that 2 and that 3 and get 6? You have to multiply them together. Okay? So that's the trick. When you're doing a chain rule, you do the derivative of what's left after you take the substitution out and multiply it with the derivative of the little piece that you substituted. Okay? So it works kind of like this. And if you're good with fractions, this should make a bit of sense too. dy dx, which is the 6, right? That's what we were finding. The derivative of y, or f of x, same thing, with respect to x. That's what we were trying to get, right? dy dx is what we were trying to get. And we had to do dy du multiplied by du dx. Well, just look at this for a second. Does it make sense why these two things are equal? Just thinking about fractions. What happens with those fractions? The du's would cancel, leaving dy dx, right? So even in that sense, it kind of makes a little bit of sense there. But that is the chain rule, though. Okay? So we have to do this multiplication of the derivative of the inside, whatever it is. So let's go back to our first one then. See if we can take that idea and get the derivative of sine of x squared. Okay? And with all of these, like I did in this one, it's probably easier if you drop the f of x and just make it a y. Okay? So I'm going to turn it into a y instead. And my u is x squared. So now I'm at sine u. And so I can do my dy du step here. So what is dy du? We just did some trig. Cosine. Cosine of what? U, right? Because u is the variable now, so it's cosine u. All right, and then I'm going to hop over here, and I do my du dx, which should be what if it's x squared? 2x. And so if I follow the chain rule, it says my answer should just be those two multiplied together, right? So dy dx, which is what I'm really looking for here, equals, and I'm going to just put the 2x in front just because it looks better that way. So 2x cosine u. What's the problem with that, though, right now? I don't have a what? Yeah. I've got an x in there, and I have a u in there, but hold up. It's supposed to be dy dx. And this little guy on the bottom here tells you what variables should be in there when you're done. And I have an x, but I also have a u. So what do you suppose I could do to get this thing so that it's just x's now? Right, because I know u is x squared. So I do a little back substitution here at the end. Okay, u is supposed to be x squared. Okay, make it x squared then. And then I got what I want. So remember when I said people often think that the derivative of sine of x squared is just cosine x squared? They're close, but not exactly right. It is 2x cosine x squared. Okay, so that's the process that we're going to keep using here with the chain rule. All right, give you a few more to take a look at here. You'll practice this just a little bit more. So let's do square root of 1 minus x squared. So the first thing that you have to do is you have to be able to recognize where did the substitution happen. So what would make a good u so that after you get rid of that stuff and make it a u, you can actually do the derivative. Okay? Sometimes it's more obvious than others. So this one, anybody think they got what that u piece should be? So where does it appear a substitution happened to make this function? Exactly. 1 minus x squared. All right, and then I rewrite that equation with the u, and it would just be the square root of u. Okay? And like I said, the goal is to do some sort of substitution or take away a substitution so that what you have left over is something you guys are capable of doing a derivative of. And can we do a derivative of the square root of u? Absolutely. Yeah, we can do the power rule for that. It's fine. Can we do the derivative of 1 minus x squared? Absolutely. If these two things are accessible, if you're able to do both of these two, you're good to go. You're going to be able to finish it. So we're going to do our dy du and our du dx. So can somebody tell me what is dy du? If it's the square root of u. Mm-hmm. And that one, remember, we've looked at a little bit in the past, and we did work on simplifying that, and it came out to 1 over 2 square root of u. So we can just go ahead and convert that one, doing our exponent rules there. Okay, and then what is du dx? Negative 2x, good. Okay, and then chain rule says multiply them together. So our dy dx is negative 2x times 1 over 2 square root u. But again, we got to do that last little back substitution into there. So what was u again? Oh yeah, 1 minus x squared. So put that back in. And then we can check to see, is there anything that we can like cancel, use to simplify a little bit, make it not look quite so crazy? Anybody notice anything there? 2's should cancel, correct. And then that x, I could just bring it up on top and do that. So our final answer here, all cleaned up, would be negative x over the square root of 1 minus x squared. All right. All right, let's do one more to make sure we got it. And then we'll go to the, what's called the power chain rule, which is like if you have to repeat this process a couple of times to get something to work. So let's see, what could I do for this one? Oh, we had that one from your last assignment I said maybe we could go back and do. Is that the cosine of 2x? Well, let's do something else. I'll do kind of a almost the same as that. How about that? Put an extra little wrinkle in the game here. Sorry. X cosine 2x. Okay, so this problem right here is not only a chain rule problem, but it's a product rule problem too. Does everybody see that? How kind of the big problem, looking at it like from far away, is basically a big product rule. And in that product rule sits a chain rule you're going to have to take care of. Okay? So the two products here are x, and then you've got your cosine 2x. So I would just start doing your product rule, okay? And in the process of doing your product rule, you're going to come to a point where, oh, now I need to use the chain rule. But wait until then. Don't try to like do everything at once, okay? So we'll just follow that procedure here. So product rule says you take the derivative of the first one, which is 1, times the second piece, cosine 2x, plus the first piece, x. What? And now we need to do the derivative of cosine 2x, which is going to require our chain rule, right? So, eventually you'll be able to just write it down. You can do some of these chain rules in your head. But for now, we need to write this thing out. So our y function is cosine 2x. What would be the u substitution for that? (2x). I think I heard somebody whisper it. Yeah, 2x. And then, so then we've got y equals cosine of u, and then we got u equals 2x, so our du dx and our dy du, we can get both of those pretty easily, right? Du dx would be 2, and dy dx would be negative sine, and I'm going to just make the back substitution right now, negative sine 2x, right? It would be negative sine u, but negative sine 2x. And then you multiply those together. So, negative 2 sine 2x. And then again, simplify, simplify, simplify as much as you can. So we end up with cosine 2x minus 2x sine 2x for that. I know you see the 2x twice and you're thinking maybe something would happen with that, but nope. One is in the sign, one's not. There's no cancellation or anything that's going to happen with that. So that's it. That's as far as you could take that one. Okay, so the power chain rule. This is if you have a substitution in a substitution. Okay? So, I think it's probably best if we just start with an example here. So what if we had something like y equals the cosine of the square root of 3x plus 5, maybe. Okay, so you kind of want to work outside in, okay? So look at the whole thing. What would be, do you think, your u? Okay. So I'm going to make my u square root 3x plus 5, and then my y over here is cosine of u. All right, and I need to do the derivative of each of those, so, whoops. This would be dy du and dy du would be negative sine u. And then, okay, I got to come over here and do my du dx. Oh, crap. I can't do that, right? Because the square root of 3x plus 5, doing the derivative of that is going to require what? Another chain rule, right. Okay, so do it again. So to do du dx, I've already used the letter u, so how about v? Let's go one more in the alphabet. So now I need to pick a v, which, what do you suppose would work for this one? 3x plus 5. Okay, and so then I got to do my I got to rewrite my u with the v in there now. Okay, so u becomes the square root of v because of this, right? I just took the 3x plus 5 out, and now it's a v. So now I got to do du dv, which I can. So that's going to be that 1/2 v to the negative 1/2, and we'll simplify all that later. But then I also have a dv dx that I need to take care of over here now. What's that? 3. Okay, so these two derivatives that I just came up with, I have to use together to get my du dx, right? Du dx would be du dv times dv dx. Okay, I'm just doing another chain rule. Okay, I know it gets confusing because there's all this stuff kind of written all over the place, but have to kind of keep that straight. Okay, so I'm going to simplify this up a little bit. Okay, so I need to do a back substitution because I know v is 3x plus 5. So I can take that 3x plus 5, put it back in, do some rearranging and such. So that's what I'm going to do next. Okay, so the 3 can come up top, and then we've got 2 square root of v, but v is 3x plus 5. Okay, so my du dx ends up being that, 3 over 2 square root of 3x plus 5. And remember, my du dx needs to be multiplied by the dy du. Right, so those two need to come together to do my dy dx. And so for that one, I've got negative sine u, and then all of this garbage I just came up with. Okay, so those two multiplied together give me my dy dx, right? Because dy du and du dx come together to make the dy dx. There's only one thing I got to do here yet, though. What have I still forgotten? Put the u back in, right, for the final answer here. So I've got negative sine of the square root of 3x plus 5, and then that multiplied by 3 over 2 square root 3x plus 5. Okay, and no, those square roots do not cancel. Why do the square roots not cancel? One's in the sign, one is outside the sign. You cannot cancel things like that. One inside, one outside. So, yeah, so this would be your final answer for this one. There's nothing more you can do with it. Even though it looks like there should be, you can't. Okay, so power chain rule, you got to try and keep yourself organized. Okay, that's basically it. I mean, the concept is not crazy hard, but it's just keeping organized and know this has to go to there, that makes this piece, and then this piece and that piece have to go here and can make the next one. So just be careful with that, okay, as you go along doing those. Okay, very last thing I want to talk about is doing the chain rule with some unknown derivatives, okay, because there's a couple questions in your assignment that are like this. So or unknown functions. Okay, and it's probably important to show you the chain rule using Newton notation for this one. Okay, because you're going to use a lot of function notation, f of x, g of x, that sort of thing. And so the chain rule written in Newton notation looks like this. See if this makes sense. So if you want to do f prime of g of x, again, a substitution happened, that is equal to hold on a second, did I write that right? F prime of, I don't want the prime there, I want the whole thing. Sorry, I got to write it this way. So you want the derivative of this whole thing, so it should be that prime equals f prime of g of x multiplied by g prime of x. That's how it should look. So what this is saying is, if you want the derivative of this whole thing, then you do the derivative of f with the little substituted piece still in. Now this is that back substitution thing I talked about, when you take the u and put it back in at the end. So you do the derivative of what's around it, and then you put the original back in, and then you multiply by the derivative of the u, of whatever was plugged in. Okay? So let's say that I want let's make this a 2, sorry. So let's say we want to do the derivative of f of x squared if f of 2 equals 3 and f prime of 2 equals negative 1 when x equals 2. So I want the derivative at x equals 2 of this thing. Okay? So if it helps, the u is just f of x. Okay? So if you want to think of it that way, that might be helpful. So just make your u f of x. And so then we're going to do our dy du, and we're going to do our du dx. Okay? And in this case, remember y, once I take that u out of there, is simply u squared now, right? So let's do these two little pieces then. So dy du would be what then? 2u. And what's du dx? Because I don't know what f of x is, right? So all I know is I need to do the derivative of, okay, f prime of x. Just have to leave it like that because I don't know what it is. So just call it that. All right? And then the chain rule said multiply these two things together. So if I'm going to do dy dx, I got to take 2u and multiply it with f prime of x. But the u was f of x. So my derivative ends up being that. 2f of x times f prime of x. So there's no actual function. Like I said, it's an unknown function. But I still have kind of sort of a formula that I can use. And if you look at the information that was given to you guys, we can plug this in now. All right, because remember, I want the derivative at 2. So if I want the derivative at 2, my dy dx is going to be this. 2 times f of 2 times f prime of 2, right? So then I can just do f of 2 is 3, f prime of 2 is negative 1. So this becomes 2 times 3 times negative 1, so negative 6. So I can actually get a value for the derivative, even though I didn't know what the original function was, simply by knowing this little bit of information up at the top here that I gave you. Okay, so still doing chain rule stuff here. Okay, still follow that same kind of pattern like we did before, but you're just going to have like f of x and f prime of x floating around in your answer when you do it that way. Okay. All right, that's all I got. Check course sites. There should be 2 things you need to accomplish: the homework assignment, and there is also a little activity for you there as well.